Construction number 1. In this, we are supposed to divide the given line segment in the given ratio. According to this particular construction, we are supposed to divide a line segment in the ratio of 3:5. We are not given any measurement of the line segment, so we are free to select whatever the measurement of the line segment that we require. So what we are going to do is, I am going to pick up a line segment. Supposing, let us call that line segment as, say, line segment AB. This is line segment AB. Now I am supposed to divide this line segment into the ratio of 3:5. The first thing that we shall draw is ray AX, such that angle XAB would be an acute angle. On this point, on this ray, I am going to select any point, arbitrary point, that is, say, point C. Now I will divide this line segment AC in such a way that we get 8 equal parts. How did we get that 8? Because we are expected to find out the ratio of 3:5. So I am going to select a suitable radius. That radius should be small enough so that it is smaller than 1/8 part of this line segment AC. Let us draw this arc. You are free to select whatever the radius you select, but take care that you do not select very big radius. So here we get point A1, then A2, A3, A4, A5, A6, A7, and lastly A8. Let us label them as this is A1, A2, A3, A4, A5, A6, A7, and A8. Now I'm going to join point of intersection of ray AX and the arc of ray A8 with point B. So let us draw the line segment, that is A8 point B connected to point B. Now because I am supposed to divide this into the ratio of 3:5, I am supposed to draw a line segment passing through A3 such that it should be parallel to line segment A8B. Now for that, what we require is the construction of congruent angles that we have studied in the lower standard. For that, taking A8 as the center and any suitable radius, we will draw an arc which intersects both, that is ray AX and line segment A8B. Taking the same radius, I have not changed the radius, taking A3 as the center, and I shall draw an arc of the same radius. Take care that you draw a little bit bigger arc. Now, with this point and this point, we shall measure the radius, and this is the radius that I am going to take up. It is simple construction of the parallel lines. And taking this as the center, and I will draw an arc which will intersect the previous arc. And that line I shall join with A3. And that ray is going to intersect line segment AB at some point, say point P. Now you can see that this ray and line segment AB8, they are mutually parallel. And because A to A3 is 3 divisions, and from A3 to 8 is 5 more divisions, exactly the same way AP is to PB is also in the ratio of 3:5. In example number 1, we are expected to divide the given line segment into 3 congruent parts. The process of construction remains the same as construction number 1. Here also we are not given any measurement of the line segment, so we are free to select them on our own. Let us draw a line segment and let us call that line segment as, say, line segment AB. Then we shall draw a ray AX which is such that angle XAB should be an acute angle. Now, taking any arbitrary radius, we shall draw 3 arcs that is on ray AX, that is, say, intersecting at A1, then at A2, and then at A3. I shall draw A3, I shall join A3 with B. Then I should draw lines which is passing through A2 and A1 which is parallel to line segment A3B. For that, I am supposed to draw an arc. That is nothing but same as construction of congruent angles. An arc which intersects A2, A3 and A3B at 2 distinct points. Same radius from center taking A2 and from point A1 also, taking care that these arcs should intersect ray AX at their respective points. Now, I am going to measure the radius from this point to this point, and then I shall construct an arc on the previously drawn arcs. And I am going to draw the rays passing through A2 and A1 through these arcs. And you can see that this one is parallel to A3B. And same way, this also is parallel to the previously drawn both the rays. Let us call these points as, say, P and Q. So, A1 is same as A1, A2 is same as A2, A3. And therefore, AP will be same as PQ will be same as QB. That means we have divided them into 3 equal parts. Construction number 2. Construct a triangle ABC whose sides have length equal to 2/5 of the length of the corresponding sides of triangle APQ. We are not given any measurement of the triangle, so we are free to select whatever the measurement of the triangle that we would like to select. Let us construct first of all triangle APQ, because with the reference of that particular triangle, I am expected to draw triangle ABC, whose scale factor is given to be 2:5. Supposing this is triangle APQ, slowly and gradually I am getting triangle APQ. Now for this triangle I am supposed to draw another triangle whose scale factor is 2/5. That is less than 1. From point A we shall draw a ray, say ray AX. Now the scale factor that is given to us is 2/5, and because of that reason I shall draw 5 different arcs of same radius, any arbitrary radius, on ray AX. Let us call them as, say, this is A1, A2, A3, A4, and finally A5. And we shall have to label them, that is A1, A2, A3, A4 and A5. Now I am going to join, because the scale factor is less than 1, I shall join A5 with P. And what about if the scale factor would have been greater than 1? That we shall see a little bit later on. Let us first of all finish up this particular construction. Now, because the scale factor is given to be 2/5, so the next line segment that I should be drawing is passing through A2, but it should be parallel to line segment AP5. For that, I am supposed to construct congruent angles, as you know that. Now, taking any arbitrary radius, I shall draw an arc over here, which intersects both AA5 and line segment AP5. Same radius, I am not going to change the radius, but now A2 as the center, and I shall draw an arc. Take care that you draw a little bit bigger arc. Now I shall measure this radius and try to draw the angle congruent to this one, so that we get parallel lines. See, I am taking this much amount of radius, and with the same radius I shall draw an arc taking this point as the center, and a line segment will arise from point A2, and that is going to intersect line segment AP at point, let us call that point as, say, point B. Now I shall draw a congruent angle, or else a line parallel to QP passing through B. So for that, once again we require an arc and same radius, not changing the radius, taking B as the center, and measuring this much, we shall draw an arc over here, and when we draw a line segment passing through this point B, then that line segment is parallel to line segment PQ, and that is going to intersect PQ at point C. So here, triangle ABC is the required triangle whose scale factor is 2:5 with triangle APQ. Now we are given a triangle APQ, and we are expected to construct triangle ABC whose scale factor is equal to 4/3. I think that is bigger than 1, and let us see how do we draw that. Before we proceed further, what we require is we need to extend line segment AP. That means we shall draw this ray, and also we shall extend ray AQ, because the new triangle is going to be bigger than this triangle. Once again, the initial step remains same. Draw ray AX such that measure angle PAX is equal to less than 90. Now in the given scale factor, what is the bigger number? The bigger number is 4, because 4/3 is the number given to us. With any arbitrary radius, draw 4 arcs, that is A1, A2, A3, and the final one, that is A4. And don't forget to label them, that is A1, A2, A3, and A4. Remember, if the scale factor was less than 1, we used to join the last point with P. But here the scale factor is bigger than 1, so the given number, the smaller number is 3, and I am going to join A3 with P. And we should draw a line passing through A4 parallel to line segment A3P. And you know how to draw that parallel line. Any arbitrary radius, and same radius. Now A4 is the center. Measure this radius from this point to this point of the original arc, and taking this as the center, draw an arc, and that is going to give us a line which is parallel to the previously drawn line segment A3P, and that is going to intersect this ray at point, say, B. Now once again, I am supposed to draw a line segment which is passing through B and should be parallel to PQ. So for that, once again, the construction of congruent angles. Any arbitrary radius, but now the same radius. Now measure, what is this measurement? Radius. Coincidentally, it is exactly the same thing. And same way over here. And draw a ray which will be parallel to line segment PQ, and that is going to intersect the next ray at point, say, C. That means here triangle ABC is the required triangle whose scale factor is 4:3 with triangle APQ. We are expected to draw a line segment AB of length 7.4 centimeter and divide it into the ratio of 5:7. So first of all, the line segment of 7.4 centimeter, starting from 0 and right up to 7.4. See, this is right up to 7.4, and let us call that line segment as line segment AB. Now what? Now, any suitable ray such that angle XAB, ray AX such that angle XAB is how much? That should be an acute angle. Now the number given to us is very big, and therefore when we draw this thing, we take care that when we select this point C and draw those points A1, A2, A3 and so on, just like in the given first construction, with a small radius. It should be smaller than 1/12 of AC. So, because 5:7, so 12 parts have to be drawn. Let us call these as A1, A2, A3, A4, A5, A6, A7, and so on, A8, A9, A10, A11 and A12. Always confirm whether you've drawn the regular required number or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because for so many arcs, you might make a mistake and draw either 11 or 13 arcs. Let us label them as A1, A2, A3, A4 and so on. You know that it is always better to check further than to make mistakes. And this is finally A12. And we shall draw line segment A12B. Now because the ratio is given to be 5:7, I am going to draw a line passing through A5 and parallel to line segment A12B. And for that, again the same thing, the construction of congruent line angles, that is construction of parallel lines. Any arbitrary radius, I am selecting a big radius and then an arc over here, same radius from point A5, an arc this way. And now measure what is this radius. It is slightly smaller. It can be smaller or bigger, doesn't make any difference. And taking this point, see, this is the radius that I have selected, and taking this point as the center and arc, and there will be a line passing through A5 and this point, and this is going to be parallel to A12B. And supposing it intersects line segment AB at point P, and here A to A5, 5 parts, so AP is 5 is to PB is remaining 7, so 5:7. We are supposed to divide a line segment into 3 parts in the ratio of 2:3:4 in the same order. 2:3, that is 2 plus 3, 5, and is to 4, so 5 plus 4, that is 9. So we are given to divide this one into 9 parts. Once again, we are not given any specific length of the line segment, so we are free to select whatever the length that we require. Let us draw a little bit bigger figure. So over here, let us call this line segment as, say, line segment AB. What will be the next step? Ray AX such that angle XAB should be an acute angle. How many parts should I draw on this ray AX on which I have selected point C as our arbitrary point? And 9 any suitable radius, but should be less than 1/9 of the line segment AC. So start plotting the points, that is A1, 2, 3, 4, 5, 6, 7, 8 and 9, and label them as you know how to label them, starting from A1 and reaching right up to A9. What is to be drawn? Yes, that is A9 to be constructed with B, that means to be joined with B, that is line segment A9B. Now another line segment 4. So count from this. This is 1, 2, 3 and 4. Passing from A5 parallel to A9. And I think once again you know how to draw this. Any arbitrary radius, an arc which intersects ray AX and ray line segment A95 in 2 points. Same radius from point A5. I'm going to draw an arc, and that arc should be slightly bigger arc. See, this way. And measuring this much radius and drawing it from this particular center, an arc over here. And that is going to intersect line segment AB at some point, and here this ray is parallel to line segment A9B, and let us call that point as, say, point Q. Then 2 parts, that is counting 3 parts from here, 1, 2 and 3. So I should draw a line starting from A2 and parallel to both of these. Once again, selecting the same radius as the previous one. A2 is the center, and I'll draw an arc like this way, and taking this as the radius, I shall draw an arc over here. And that line A25 is going to be parallel to A5PQ. Let us call this point of intersection as P. So A1, A2, that is 2 parts, so AP is 2 parts. From here 1, 2 and 3 parts, so PQ is 3 parts. And from here 1, 2, 3 and 4, so QB is 4. So the ratio is 2:3:4. We are supposed to construct a triangle whose sides are given to be 4 cm, 5 cm and 7 cm. And construct a triangle similar to this triangle whose sides are in the ratio of 2:3 to the lengths of the corresponding sides of the first triangle. So first of all, let us draw the triangle. You can start off with any of the side first. I prefer that the longest side should be drawn as the base of the given figure. So the longest side of the given triangle is, say, 7 cm, and this is the line segment of 7 cm. Let us call this line segment as, say, BC. Now because I am supposed to construct other 2 sides as 4 cm and 5 cm, so I am going to pick up a radius of 4 cm this way, and then taking B as the center, you could have taken C also as the center, because we are not given any specific name. I can draw an arc this way. Then taking 5 cm as the next side, so 5 cm as the radius, and taking C as the center, cut the previously drawn arc. And let us call this point as point A. Now the given scale factor is 2:3. That means it is smaller than 1. So I am not going to extend ray BA, but I am going to draw exactly line segment AB and line segment AC. So at the end of this, we got our required triangle. Now we require another triangle similar to this one whose scale factor is 2:3. You know the method that we are supposed to draw ray BX such that measure angle B is, that means the measure angle CBX is less than 90, that means it should be an acute angle. 3 is the bigger number in the given ratio 2:3. So I'm going to take up any arbitrary radius and draw 3 arcs, 1, 2 and 3. Let us call these as B1, B2 and B3. Now join B3 with point C to get B3C. Why? Because the scale factor is less than 1, so the bigger number to be joined with this point. 2 is the smaller number, so I am supposed to draw a line segment parallel to this B3C passing through B2. And for that we require once again construction of parallel lines. Any arbitrary radius, and let us see the first arc. Then same radius from B2 as the center, another arc. And measure this radius, and then from this point we shall draw an arc over here. Join it with B2 to get line segment, say B2P, which is going to be parallel to line segment B3C. See, both of them are parallel, and let us call that point as P. Now, once again, from point P, I am supposed to draw a line segment parallel to line segment AC. So, C, any arbitrary radius, an arc. Same radius, P is the center, and another arc. Now, I am going to measure this much radius and draw an arc over here. Draw line segment PQ through the given point, and as you can see that this is parallel to line segment AC. Let us call this point as Q. That means triangle ABC similar to triangle QBP, where the scale factor is 2:3. Triangle PQR, measure angle P is 60, measure angle Q is 45, PQ is given to be 6 cm. We are supposed to construct triangle PBC, whose length is 5:3 times the length of the corresponding sides of triangle PQR. So first of all, let us draw line segment PQ of 6 cm. Now the given scale factor is bigger than 1, that is 5:3. So what I am going to draw is somewhat directly like this, because I am going to require the ray after that. So I am going to draw a ray which is bigger than 6 cm. I shall mark out a point over here at the distance of 6 cm, and that point will be called as, one of them is P and the other one is Q. Now, point P, angle P is going to be 60. So, you know how to construct 60 degree with the help of the compass without using the protractor. So, first of all, any radius and then the same radius, and this ray is going to be the ray of 60 degree. I shall keep this ray open until I get the second ray which is going to intersect this particular ray. I am not going to draw this arrow at this particular moment. Once again, at point Q, I am supposed to draw 45 degree. And you know how to draw 45 degree. There are two methods of drawing 45 degree. One is construction of 90 and the bisector of that. And the other one is construction of 30 and 60 and the bisector of 30 and 60. I am drawing by the first method where the angle is going to be bisector of 90. Now this line would be a faint line or a dotted line because we are not going to require this line in our main construction. And bisector of the point of 90 degree and the point of 0 degree. And this angle is going to be 45, intersecting the previously drawn arrow ray at point R. Now I am going to extend this ray because the scale factor which is given to us is 5:3. In fact, I should have extended right into the beginning instead of drawing any joints. Now, how to draw triangle PBC whose scale factor is going to be 5:3. Draw a ray PX of any measurement. In fact, rays don't have any measurement, and the bigger number of the scale factor is 5, so 5 different arcs of any arbitrary radius. So P1, 2, 3, 4 and 5, labeling them as P1, P2, P3, P4 and P5. The smaller of the two number is P3. So first of all, P3 is to be constructed or is to be joined with Q. Now, a line passing through P5 and parallel to line segment P3Q. And you know how to draw that. Any arbitrary radius, a big arc intersecting them at both the points, same radius. P5 is the center now, and measuring this much center radius from this point to this point, and we shall draw an arc intersecting the previously drawn arc. When we join them, then this point is going to be point B. Now, B as the center, or B as the initial point, and we are supposed to draw a line segment which is parallel to line segment QR, this QR, and for that once again the principle remains same. Any arbitrary radius, B center, same radius, and measure this. I hope you know that this angle is going to be 45 because angle Q was also 45. And joining this, and this ray is going to be parallel to the given ray, parallel to line segment QR, intersecting this particular ray PR at point C. So, as you can see that triangle PBC is the similar triangle to triangle PQR whose scale factor is 5:3. Triangle ABC, measure angle ABC is going to be 90, BC is 4 cm, AC is 5 cm. And we are supposed to construct triangle BXY such that the scale factor is 4:3. That is once again bigger than 1. First of all, line segment BC of 4 cm, or else a ray whose measurement would be bigger than that of the 4 cm. Why? Because our required triangle is having the scale factor which is bigger than 1. So, first of all, the big ray and a point on that will be point C. So this is point B and this is point C. Let us call this as a ray. Now, measure angle ABC is going to be 90. So I am supposed to construct 90 degree at point B. You know how to construct 90. First of all, the arc of 0. From 0 we get 60. From 60 we get 120. And in between 60 and 120 we get 90. Now we'll draw a ray which is open ray, and we are not going to draw that ray at this particular moment, but a big one. Now AC is given, and AC is going to be 5 centimeter. So measure 5 centimeter on the scale, a radius of 5 centimeter. C is the given center, and I'm going to draw that, and this is going to be point A. And draw line segment AC. If your construction is correct, then theoretically you know that if BC is 4 centimeter, AC is 5 centimeter, then AB has to be 3 centimeter. And see, it is 3 centimeter. Now, a scale factor of 4:3 for triangle BXY. Any suitable ray, such that, say ray BP, such that measure angle CPB is an acute angle. 4:3, the bigger number is 4, so any suitable radius, and I'm going to draw 4 arcs on this. 1, 2, 3, and 4, and calling them as B1, B2, B3, and B4. The scale factor is 4/3, so the B3 is to be connected with C. Then any suitable radius, B3 as a center, an arc. Same radius, B4 as the center, an arc. And because the size of the figure is small, this is going to be slightly confusing, but then also concentrate on the number, on the figures. And taking this radius, same radius, draw an arc, and that is going to give us a line segment which is parallel to line segment B3C, intersecting this particular ray at point X. Now, from point X, we are supposed to draw another ray. Let us close this, and for that, C is the center. Any suitable radius, take up a small radius, and same radius, take up C as X as the center, take up a radius, measure this radius, whatever this radius might be. It's a small radius, but this particular radius, this one, and draw an arc over here. And that is going to give us line segment XY. So over here you can see that BXY is the required new triangle. Line segment PQ of 6.5 centimeter is given, and we are expected to divide it in the ratio of 4:7. 4:7, this is very much similar to that of the first example, first construction, and also the question number 1 of the same exercise. 6.5 centimeter. Here it goes. And this name is line segment PQ. Ray PX, such that angle XPQ should be an acute angle. Taking any point C on that, arbitrary, how many divisions should I convert this or divide this into? 4 plus 7, that is 11. Don't take very big radius. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and at last 11. That is P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, and P11. P11 to be joined with Q. Another one, because starting from P4 parallel to P11Q. Any suitable radius? I would prefer to take a little bit bigger radius and draw an arc. Same radius, P4 center, draw an arc. Measure what is this radius and draw an arc over here. And when we join it with P4, that is going to be parallel to P11Q. And supposing this point is, say, A. P1, P2, P3, P4, so these are 4 parts, so PA must be 4:2. From 4 to 11, that is 7 parts, so AQ must be 7. So this is how we divide it into 4:7 parts.